Just quickly, again, I already showed you before, but the derivative is you choose the interval dx. We're going to use delta x, but dx actually is also legal way to call it. So you don't have to write it down, but we know this formula. You need to know this formula for the test. And in general, it's kind of just very important. So you choose a time interval. For example, 5 seconds. I want to see if Superman can change to Clark Kent in those 5 seconds. And then I see here's a Superman sitting plus this 5 seconds, right? Minus where he was sitting right away when I clicked the camera click. And will I see with the camera how Superman changed to Clark Kent, or it will still be a secret? So we're finding the row change. The row change is just output. So I want to take the average. To find the average, I'm dividing the change of the Superman over the interval 0.5 seconds, right? Or did I say 5 seconds? Let's stick to 1. Let's stick to 0.5 seconds. And that was not enough. 0.5 seconds, I still do not catch Superman changing it to Clark Kent. I still see Clark Kent and again Clark Kent. So how to reveal his identity? I want this model to be perfect by doing what? The time interval shrinks to 0. And how to do that? You use limits. That is where it's coming from, the limit. You're never gonna shrink to 0. It's not like there's a 0 seconds of time. It's still gonna be 0.00001. So limit tells you that. Limit can take you to 0 as close as you want to catch Superman, at least with the camera. So math makes it ideal. That's why it says make your model perfect. This is the definition of the derivative, which you need to know. Now, I want to tell you how to, I guess some definitions are important. Let me give you some definition. Let me first tell you how to identify that they want you to find derivatives. There will be some kind of synonyms you see. So, because English is not my first and not my second language, I like to teach students to see keywords. Okay, you're reading this long problem on a test. You don't have time for this. You see my keyword, you know what to do. If you see they ask you to find slope, don't hesitate. You find derivative. So that's going to be one of the things to do. They want you to find derivative at the given point A. Slope, done. Then, in some problems in the homework you already see, they ask you to find velocity. Velocity. Sometimes it's also speed. Velocity and speed, surprisingly, is not the same thing. We're going to teach you later. One cannot be negative. Like, what is my speed? 55 miles per hour or minus 7 miles per hour. It cannot be negative. But the other one can. So it's just physics definition. You can Google what physics says about that. You see this, you'll see in your homework, maybe on the exam, maybe even on the final exam. Find the velocity, blah, blah, blah. Don't think twice. You take derivative. That's how your hand will feel confident taking derivative. Your brain comes down, and now you know what to do. I think the hardest part on the test is to start, right? Like, what should I do? So that's what you do. You take derivative. You will not see this in this class, but for business students, we teach marginal of cost function, marginal of revenue or profit, revenue function. That's how fast cost changed of my business, how fast profit changed. Marginal, that's derivative. You will see phrases like find rate of change. Rate of change. This one you should be careful because if it's average, you don't take the limit. So that's kind of important to remember, but it's still about derivative. Then in general, you will see the words rate. At what rate something happened? That's derivative. You will see the word per, especially if you're not English speaker. Per is this slash, the slash. Miles per hour, that's speed, that's derivative. That's derivative of distance. Or 5 grandmothers per hour going to the Home Depot, okay, to buy something at 8 in the morning for some reason. That's how fast the number of people are changing in the store. That's derivative. So rate or pair. And I just mentioned how fast. If you see how fast, take derivative. 90% chances you're doing correct. You're doing the correct step, the first step. So that's how you read English fast in the math class. And finally, you know this one, instantaneous rate of change. One more time, I'm going to write it down completely. Instantaneous. O-U-S. Can you write this down word without checking correctly? It's very hard. Rate of change. That's a hard word. That is also a derivative. So this is my hint for you. You see those things? You know how to do what to do on the test. On the homework, you have time to think, but on the test, do you? American testing systems wants you to be fast. They don't give us chances. The slow people like me, they don't give us second chances. You're too slow, out. Super stressful. I feel like it's not fair. It's a race for some reason. Why would you do race in the STEM major? That doesn't make sense to me. You're a thinker. Let me think. But this is how I teach it. You see keywords, you know how to do, you get A on the test. On the homework, you can take 3 hours if you want to think about it. Now, you will see different notations of the derivatives in your life, notations. So if you want to know what is important for your major and what is not, you will see derivative everywhere. People who are working in architecture, derivatives every day, civil engineers every day, physicists every day. Computer scientists, I don't know. I think computer scientists are coding every day, so what do they code? Nobody knows. It's just a fact. Nobody knows what they're doing. So it's just, you guys gonna become computer science, you should tell us what you guys are doing. F prime, you saw that. Y prime, derivative. The professional official name will be df over dx. That is not a fraction. That is a notation called derivative of f with respect to x. Derivative of function f with respect to WRT, but write down with respect to x. This will be very important in calculus 3. For now, it's just df dx. You will also see dy dx. And not very popular, but American books like to do it sometimes. Capital D of f, derivative of f with respect to, shouldn't be y, should be x, with respect to x. Like so. That's not a popular one. I never seen it in the books many years until I came to the United States and they have it here. But just for you to know, not to be surprised, this is the most important, and we're gonna do y prime, f prime for the speed purposes. So that's the same thing. That's called derivative. We're gonna learn partial derivatives in calculus 3 with a cute little circle, df dx. That's gonna be in calculus 3. It'll be very pretty. Okay, theorem. Not all functions have derivatives everywhere. Let me put notations in the nice table. So some functions are not differentiable, which means I need to define that. So let me write down first. The theorem says, for the function, in order for the function to have a derivative at the point, not everywhere, at least at the point, if and actually, let me just tell you this way. If f is, that's going to be a long word, differentiable, differentiable. That means derivative exists. So that's a definition. That means f prime exists at a. We never say differentiable everywhere. Differentiable everywhere means at any point. So in general, we're defining differentiability at the point A. Then the function is continuous. Then f is continuous, and that takes us to the previous chapters. Now it's very interesting. If you want to check if the function is continuous, you can see if the derivative there exists. At A. That's a theorem. So differentiability is a stronger concept. That's how we say it. It's a stronger concept than continuity. If f prime exists at A, f is continuous at A. There's no gaps, there's no holes. But not the other way around. But not the other way. The other way. There are many cool examples when the function is continuous, but it doesn't have a derivative. It's very upsetting. Yes?
Would the example be the one where it has a sharp point?
Sharp point. Exactly. Do you remember this kind of concept? So for people who never seen it before, don't be upset. You will see it right now. So thank you. The function should not have, remember, the function should not have, I will write down, there's no derivatives at cusps. That's an English word I did not know before learning this definition in English. Cusps are sharp angles, sharp corners. Should be no sharp corners. And I'll show you some cool animation after this. So this is the idea. Derivative, yes, everything is fine. What is that? No derivative at that point. So this is where f prime does not exist. D and E.
Because multiple tangents can be passed through there.
Yeah, we'll be going there because we're still kind of not very good at knowing what the tangent does with derivative, how the connection is between that. So you see a gap, there's no derivative. You see sharp corner, there's no derivative. That is the idea. So the function should be smooth. Smoothness is actually official definition. Smooth, nice, pleasant function. No derivative there. Even though the function is continuous. Can you give me some example from your mind? So people who know it because they saw it before, that's just not fair. Let's give other people to enjoy this new material. They never saw it before. People who never seen it before. Can you imagine a function that is continuous but has the sharp corner and doesn't have derivative at that corner? Anyone? People at the back? Yes? No? You like, yes. Yes?
Modulus of x.
What did you say?
The modulus of x.
Modulus of x. What is that? Who knows what modulus of x is? Absolute value of x. Yes. This is what you're showing. It looks like a corner or peace sign. So that's a very cool example. Example of the function like that. Example of continuous function but not differentiable at some specific point is y equals absolute value of x. It's continuous. Actually, you might not believe me, it's continuous. So maybe you can check using limits if it's continuous. Do you remember how to check if if the function is continuous at the point? You find left limit, right limit, and then f of that point should also be the same number, right? So it is continuous. You put a pencil, you never take it out. But there's a sharp corner at 0. So it's continuous, but not differentiable. And then the short way to write down differentiable is DIFF, and then you just do ABLE. Not differentiable, not everywhere at 0. So at x equals 0. So I can still take derivative at other points. It's just not at 0. There's no derivative at 0 for absolute value. So that's a cool example. Because at 0 there's a cusp or sharp corner. So you had the absolute value example in your homework. And I realized many of you don't remember the definition of it. Definition of absolute value is f of x, which is absolute value of x, equals it's itself when x is positive or 0, but it's negative itself if x is negative, like so. So that's basically the definition. In my notes, I'm actually checking for you that the limit from the left does not meet the limit from the right at 0. One is minus 1, the other one is 1. So this whole fraction will not give you a limit. And then in your homework they ask you check if derivative exists, you check this limit. If the limit does not exist, then derivative does not exist. Another way of explaining it is this way. Derivative has connection with a tangent line. Tangent line should be nicely changing slowly. So this is tangent line at the point, this is tangent line at the point, this is tangent line at the point, and more and more. It doesn't like jump suddenly until it goes to the cusp. Tangent line tangent line, and then what is happening here is like that, or like this, or like that. At the cusp, we cannot agree which tangent line to choose. What kind of slope is that? Which one do we choose? And the other idea is that it was this tangent line and then suddenly jumped to completely different angle. It's a very fast change. Derivative there does not exist. So you can put like a weird star there. It's just there's no way you can find slope tangent line, equation with tangent line there. Yes?
So on the graph of the derivative, what would that look like?
Oh, very cool question. The derivative has its own graph. In your homework, you will see that too. When they're comparing graph of the derivative and graph of the not derivative, it will be not continuous. So
would it be a jump discontinuity?
It will be a hole. So very cool question is derivative is its own function, which actually this chapter is about. It's called derivative as a function. Derivative will exist here, 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 and it will be a function. And this one will be linear, by the way. It's also here, 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 but then there will be a hole. So don't draw that. Don't draw a hole on the absolute value. That is not true. But there will be a hole at 0. So that's kind of a very cool question. You're very smart. Very cool question.
How to make the graphs of derivative?
That's, I plan to show it probably on Friday. Quickly answering is you literally draw, you see that this is a line, so you know the derivative will be constant. And then you have to draw it using the definition. Or the power rule, or with the power rule we're gonna learn literally today or on Friday. Derivative of x squared is 2x, so you draw 2x.
Is it Friday or exam?
Huh?
Is it Friday or...
Friday is quiz. Monday is exam.
Monday,
Okay, very good. Let me show you this idea in a more beautiful way. So, let's draw again. This kind of function. I will do it here. Cusp, keep going. The derivative, I will use two colors. Red for the positive derivative. Positive derivative is when you're hiking uphill. Derivative is positive. Positive derivative means the graph of the original function is increasing. You know what increasing means? You put a pencil and it's keep going up, right? So I like showing it in the form of hiking. You're hiking uphill. The steeper your hike, the higher the derivative will be. And the highest will be this vertical line. That's climbing already. So do you know what means to have zero derivative, zero slope? What kind of hike is that? Yeah? Yep. Completely horizontal. This floor has zero steepness. That's why we like it so much. So the floor will be very flat. This is the idea. Derivative is positive. Then, when there is a point at the top or the bottom, the derivative suddenly becomes 0. Because now, you're not hiking up and you're not hiking down. You're at the top or the very bottom, right? So derivative is 0. Now you start hiking down, and I will choose another color, for example, green. When you hike down, the derivative switches to negative sign, which makes sense. Positive, positive, 0, negative, negative. You're going down, and the more steeper it is, the bigger the negative derivative is. Then this is a cusp. I guess, let's make it very clear that it is sharp. Derivative here does not exist. And derivative here does not exist because of the sharp corner. But the whole approach is the same. Derivative is positive because I'm going up, and then derivative is negative when I'm going down. This will be one of the most important properties to understand. Why the rocket speed is increasing. How about acceleration? The speed is increasing, but you don't accelerate anymore. Derivative becomes negative for the acceleration. So that is a pretty cool idea. Yes?
The graph can never come back, right?
Yeah. So if it's continuous,
Then it can never come back.
Never come back where?
Like if it's going like this in the positive x direction, it can't go like this and then come back.
Oh, good question. Can it go like this? The function should be defined using, remember the horizontal vertical line tests? So it should be 1 to 1. So for now, we're only working with the functions that never go back. You're right. But we will have a circle at some point. So it's going to be cool to see what's happening in a circle. Positive, 0, negative 0, D and E, and so on and so on. Yeah, exactly. So let me show you one example from your homework. It only has 7 problems, but 7 problems, and I did solve some of them in my videos. So that's also because people got stuck with some of these. So the last problem was the Newton laws of cooling. I solved that problem because people stuck with it a lot. People in this class already did, and my previous class. So I have a video on the Newton's law of cooling, which is a pretty cool idea. So, you know, when you leave something on the table, it starts cooling down. But how fast? Depends on temperature. If it's Arizona with 100 degrees outside, it's not going to be cooling down, you know. But if it's AC, room with AC, it will cool down. And the cool story about that, let me probably write down one example and we move on to the next chapter while I'm talking about how hot the earth is. So it's a very cool idea here that, and I'll write down this like example while I'm talking about the earth example. If you Google the Wikipedia or any history, you will see that people were debating about how old the earth is. And they decided to figure out through the Newton's law of cooling. Because if you know how hot the potato was after you microwave it and you put it down on a table, you know the speed of it cooling down. Then you can figure out how old it is. So when was it hot at the first time and now it's completely cold? There's a time passing by. So this time can tell you how old the core of the planet is as well. So they kind of compared the planet to a potato. It was actually like really a potato idea. Potato has a center. The center stays hot till the end, right? Everything cools down from the outside and the center is still hot. So when you microwave the potato, it's cooled down from outside to inside. Well, they said, you know, the planet also has a core and it's still hot. But the outside of the planet is not as hot anymore. So if we can figure out those temperatures, we can figure out how old the planet is. When was it completely hot on the edges? And now it's not. It worked. People figured out, they calculated using Newton's law of cooling the planet age. So I will put this using the definition in yellow because in the test, if you see this phrase, you cannot use any other methods to get points. And they figured out the age of the planet was very young. When they published the results, biologists did not like that. And archaeologists did not like that. Archaeologists said that's way too young. Dinosaurs could not extinct that fast. And biology says there's no freaking way the species would evolve that fast. But physicists were kind of very confident about this. So there was a professor who was fighting for this idea that they are right. They published the result about the age of the planet. And then the professor actually passed away before the result was not accepted anymore by but his own son. His son actually chose the other side of the science. That basically was a breakdown between scientists. Is it correct or it's not correct? So his own son says, I don't think the planet is that young. It probably is older. And then they proved it later. Do you know why the Newton's law of cooling did not work? Guess. What is the difference between a hot potato microwaved and now it's standing on a table cooling down with the planet Earth? Guess. What? Still being heated, but by what?
Sun?
The sun, a little bit, but I guess not as significant as you can imagine.
There's no heat sink.
What?
There's no heat sink.
He
He can't go anywhere.
He doesn't go anywhere. Interesting, yeah?
The core cools down a lot slower than an actual...
That is correct. The core cools down slower. Why? Why is not the potato core?
So incredibly dense and there's so much pressure. Right?
That is also correct. But there was a specific terminology showed up in science. Just a second. Some specific terminology was show up in physics that they did not use before. That's what they find out is in the middle of the planet. Our planet has something cool in the middle. What is that? Radioactivity. That actually was the first time they started talking about radioactivity and stuff. The planet is radioactive inside. Okay, there's more stuff to it. Of course, I'm simplifying it. Go into physics book and read about it in details. But the radioactivity was discovered because of that conflict. Apparently, planet is radioactive inside. Do you know what it means to be radioactive? It's keep heating from inside. Instead of cooling down, it's keep heating it up. And that's why it's still hot for so long. And that made the planet much older than people thought it is. It was. So that's a cool story. I really like the story. Bless you. Solution. Find the derivative of this function by the definition, not using the power rule, which we're going to learn on Friday, and we'll be happy about it. Steps. Let me show you steps how to do it on a test so you feel happy about it. We did one example like this on Friday last time, but let's do one more because I think it was not very clear. Let's find f a plus h first. What is f of a plus h? Well, you need to figure out what is your a first. Your a is, did I give you a? I did not give you a. Let's see. Oh, we just keep it as a, apparently, in this example. Not necessarily we're going to give you anything specific. Oh, well, okay, fine. So the answer will have a in it. So now we just plug it in. Everywhere you see x, you copy paste a plus h. Old input was x. New input now is a plus h. Copy, paste. 3a plus h. Don't forget the square. So you copy paste literally. If you know the function in Microsoft Word, it's called find and replace. Well, other programs have it too. Find and replace. That's what you do. You're finding all x's and replacing them all with a plus h. Minus 37. That's your first function. Second, find the difference. Remember that row difference we were talking at the very beginning. Step 2, find the row change. So I found the new f, and now I'm going to subtract old f. And the old f is f of a. F of a plus h, that's the original function, but changed by a little bit, a small h, minus the original one at a. That's called a row change. Now I'm going to write down all of this. It's going to be 3a plus h squared minus 6a plus h minus 37. That's the one we just found. Minus, you see color coding here is very nice, working really well because you can actually visualize everything well. That's for my visual learner students. I like doing coloring. The original one is f of a. Everywhere you see x, now you put a. 3a squared minus 6a minus 37. What do you think about that? Can you do that? That's not the end, but I wanted to ask. So, it's new minus old at a. New means a little bit change in it. Step, continue. We need to simplify this mess so we don't have to struggle with it. To simplify, what formula should I use for a plus h squared? Square? Yes. Yeah, do you know the name of it? Square of sum or square of difference formula. So usually I don't like rewriting it every time. I take a pencil. In this case, I'll take different color. And I write down a squared plus 2ah plus h squared. This is how I'm converting the square of sum. Let's keep it like this. A squared plus 2ah plus h squared. See lecture 0. I always review this formula in lecture 0. And now I'm going to distribute 3 everywhere, so I don't have to rewrite everything all the time. I speed up. 3a squared plus 3 times 2 ah plus 3h squared. That was the first term. Maybe you put it in parentheses. Minus, distribute 6. 6a minus 6h. Distributing minus 6. Minus 37. This is the first term in purple parentheses. Minus, and then you just keep whatever was there. Nothing to simplify here. Well, I guess you can distribute negative sign. Minus 3a squared plus 6a plus 37. Is it too fast? It's algebra, but I'm not claiming it as simple and easy. Remember, algebra is our biggest enemy. You will be doing triple integrals and you're still gonna lose the negative sign. That's exactly what happens in our class all the time. And people are so upset. They have such a complicated concept of viscosity and density and 4 dimensions figured out, and they lose a negative sign. So it's just very upsetting. Algebra is always there to catch you. 3a squared and minus 3a squared, gone. 6a and minus 6a, gone. 37 and minus 37, gone. So what's left? 6ah plus 3h squared minus 6h. Do you know why we're happy with this result? Because we can, yeah, what do you want to say? Factor the h out, exactly. Why do we want to do that? Because the next step is to divide by h, and we don't like dividing by 0. So finally, you can write down the limit. Let's do this last step. Limit of the row change we just found minus, well, the new minus old. That's my row change. But then we're dividing by h, and h goes to 0. We had this limit so many times. That's the definition of the derivative, by the way, at a. So I can even write down the formula. Right in front of it, I will write down this is f prime at a. This is the definition of derivative of the function at the point a. But now we know we're going to be dividing by 0. So the whole idea was to hopefully get rid of the bad guy in the denominator, which is 0. Let's factor out h. I notice h is here, here, and here. So it's going to be 6a plus 3h minus 6. And yay, I'm canceling out the h in a denominator. Now, step 1, plug in, hope for the best, or keep simplifying. I'm plugging h equals 0, and the answer is 6a minus 6. Can you do this on a test? So you will practice it in your homework a lot, and you will not like that. But the good part is that you practice it a lot, you do well on the test. That's the idea. I wanted to tell you this idea of substituting things. I'm pretty sure people have questions about this. How did we substitute stuff into things? So let me make this note. How to plug into a function, some kind of expressions, function. I like teaching it using idea of love because it's kind of cute. So if I give you f of x, that's just example, equals x squared plus 1 cube minus 5x. People who consider themselves kind of weak in precalculus, this is right now, you should concentrate. This is where it's important. And again, it's okay to be weak in precalculus, but that's why I'm reviewing for you, so at least pay attention now. If I ask you to find f of j cubed, some random stuff, how is it working? This is what you do here. You locate all x's. And instead of x, it will now be j cubed. Copy and paste. So you copy and paste. Copy, paste. That means instead of x, I will have j cubed. But what happens with 2? It's still there. Make sure you copy, paste with all the tools around it. Don't lose any operations. Minus 5 times j cubed. So this is important, how to substitute stuff into functions. And now you simplify if you want to simplify. I will ask you in the future to plug in the whole function. Can you find f at x squared minus sine x? It's the same thing. You copy x squared minus sine x, and you paste it everywhere you see x squared minus sine x. X squared minus sine x. What goes first? Square, because it was x squared, plus 1. No, it's correct. All of it cubed, that's the green one, minus 5 times the blue part, x squared minus sine squared. Does it make sense? It's called composition of functions. When there's a function inside of the function, it will be very important in this class and calculus 3 class 2. So it's kind of nesting of functions, not nasty, nesting of functions. Functions inside of the functions, like a Russian doll, which I will bring to class in some point. So I like to imagine it this way. If I ask you to plug something new, love, can you plug love in the function? Yes, you can. Doesn't matter. If it's in a domain, you can. So when you code those things in Java and stuff, that's what you're doing. You plug in velocity. Next time, color. Why yellow color is easier to see than green, than brown, and so on from the far. So how do you plug it in? Everywhere you see x squared, you put love. So it's going to be love, not x squared. Every you see x, it will be love squared plus 1 cubed minus 5 love. So no matter what I tell you, you need to know how to carefully plug it in. That's extremely important. So if you had gaps in this material, imagine it, copy and paste. Locate all x's and substitute with whatever I'm telling you to substitute. And that's what we just did for this function here. We had x, and we substituted a plus h everywhere. Does it make sense? Questions, comments, concerns? Yes?
Scroll down a little bit.
Yeah, for sure. Good job, people. Friday we have a quiz too. I will make announcement about the topics. Catch up with everything. Finish 2.2. Start 2.3. It's very nice homework to start by yourself. Have a good day.